This is the video key for the second comprehensive exam this semester. Let's take a really quick look at it. As you'll see highlighted, number 1 is asking you to factor, number 2 is asking you to solve. So that's the biggest difference between these two first questions. For the first one, factor out any common factors first, and then if there's a remaining quadratic, go ahead and factor that as well. You get a GCF in this one, so you pull out the 2, and then you have the difference of two squares, which gives you x plus 5, x minus 5. For the next one, the common factor of all of these is just x squared. There is no coefficient in common because this leading term only has a 1 as a coefficient, so you pull out the x squared, you get this quadratic, and then you factor that and end up with this pair of factors, and then don't forget this x squared out front. You're not dividing out by that. Instead, it becomes one of the factors and the leading factor, in fact. For number 2, you're asked to solve each of these equations, and now, because up here they were expressions, now we have an equation with an equal sign. The first one by factoring, so pull out the GCF, then factor the resulting piece. You can choose to go ahead and pull these two factors together to be x minus 1 quantity squared, or just leave them like they are. The most common error here was to forget this leading term, and so a lot of students that made the error just divided through by 5, then divided through by x squared, but you can't divide by the x. You have to factor it out instead, and so when you do that, you get 0 and 1. For part B, use the square root method. It's already equal to x squared, so you take the square root of both sides, plus or minus on the right. When you do that, you get this negative number inside, and because that's a negative number, we do not have a real solution, so you say no real solutions. For C, you're using the quadratic formula. Might as well push it up the rest of the way to see the bottom one. For part C, use the quadratic formula, so you pull off A, B, and C, but you can't do that in the original way it's written, so add 9 to both sides. Then A is 4, B is negative 1, C is 9. Go ahead and find B squared minus 4AC. When you do that, you get a negative number, and because that's a negative number, inside the quadratic formula, you'd have the square root of a negative, which is no real solution again. For part D, you could use any method. This one uses factoring. I know it's a 4-letter word for some of you, but it's the easiest method if you know how to factor. So bring all the terms to one side. When you do that, I recommend keeping the x squared positive. It makes the factoring a little bit easier. And then go ahead and factor your trinomial or quadratic. And when you do that, you set each factor equal to 0, and then once you have that done, you get your solution. For number 3, we've got a function. It's in mosquitoes, where x is the rain in inches in June, and they're asking what rainfall produces the maximum number of mosquitoes. So you have a couple of different options here. You can go ahead and use your graphing calculator, and we know this quadratic is facing down because of the leading coefficient. That means here at the vertex we have a maximum, and the x, y of the vertex, that x is the value we're looking for, and you can find that on your calculator, and it is indeed 9 inches. About, notice the little about sign. For number 4, you're forming a polynomial who has these zeros. We're doing a lot of work with pulling roots or zeros off and putting them back into polynomials. When you have something factored already, when you look back up here for D and it's factored, the zero property allows us to say whether something is a root or not, because setting each of these equal to 0 tells you then that x is 3 or x is negative 2 back up here on this question. Down here, when you pull those zeros off, it's saying can you go backwards and find those factors. So for negative 3, x minus the root gives you x plus 3. X minus the root for 1 gives you x minus 1. X minus the root for 6 gives you x minus 6. Now you want to have degree of 6, and to get degree of 6, the exponents have to add to 4. Because when we multiply these two together, the leading x's give you an x squared, which is this 1 plus 1. When you multiply this factor by itself 4 times, you're going to get a quadratic that's raised to the 4th power. And then you have something to the 4th power that's multiplied by a polynomial of the x squared power, and that gives you then 6th degree. For number 5, we have a demand function, and what we have been doing is following along with your book and saying that when they tell you you have a demand function, that's your price equation. And then we know that revenue is price times quantity. So the first thing, express the revenue as a function of x. We want to take x times the price. Go ahead and simplify as it asks you, and you get negative 2x squared plus 1,000x. What's the revenue of 200 units are sold? That's saying what happens if x is 200. So put 200 into the revenue function. That is the one you just created. Substitute it in and simplify to get your value. Don't forget that dollar sign. For part C, what quantity maximizes the revenue? Now this revenue function is a polynomial. The polynomial is facing upside down, and we have a maximum up here where x is the value that gives you the maximum of the y. And so they're asking you what quantity x maximizes it. We're looking for that x value of that vertex. So negative b over 2a. B is 1,000 from this function. A is negative 2 from, again, your revenue function. You just substitute that in. And then negative 1,000 over negative 4 is 250, so you get 250. What's the maximum revenue? That's the y-coordinate of the vertex. So back up at the vertex again. So take your original revenue function. We've been working with the revenue for each of these questions. Go back to the revenue function, substitute the 250 in, and then you get your max revenue. You need the dollar sign for that one as well. Then what price should you charge to maximize that revenue? You need to take the value that you have, that you found, the quantity of 250, and put it into the price function, and that gives you then 500 again with a dollar sign. For number 6, you need to take this function that you're given, x squared minus 5x, and find all of this information for it. So it faces up because the leading coefficient is 1. The vertex, negative b over 2a. Go ahead and calculate that. You get 2.5. It's okay to have written 5/2. It's okay to have written 2.5. Then to find the y value, go ahead and substitute it into the original function, so you get negative 6.25 or negative 6.25. The axis of symmetry is a line, and so you do need to actually write that as a line. So here is the axis of symmetry. It's x equals 2.5. The y-intercept is the origin 0, 0. X-intercepts, you need to show your work for that. Take the function x squared minus 5x, factor it, set each factor equal to 0. That gives you those x-intercepts. The domain, it is a polynomial, so you're going to use all x values. The range is asking you for y values. We're on to g already. So you take the lowest y value, which is negative 6.25, and it takes all y values up from there. That's what this is saying. It's increasing from the vertex to infinity, so from 2.5 to infinity, it's increasing. Decreasing over here on the left from negative infinity to 2.5, so decreasing here. And then you have to graph labeling all of those intercepts and all of the key values. The bonus question, make this a little smaller so you can see it all at once. There are a couple of different ways to do this. This is showing you one common way that students have used, and we're given this vertex form. They tell you the vertex 1 and 4, so substitute them in and you get this. Now, they give you a 0.21, so you can substitute the 2 in for x and the 1 in for y, and then go ahead and solve for a, and you get negative 3. Now, what some students do at this point is we'll write y equals negative 3 x minus h is 1 squared plus k, which is 4, and then go ahead and expand that and collect like terms. And when you do that, you end up with the polynomial, or quadratic in this case, where you have a, b, and c, and it takes a look like this format up here at the very top. And so when you expand that, you get equals negative 3x squared plus 6x plus 1, and that's your a, b, and c. So that's one way to do it. You can keep going that way, or you can go back in, use the vertex to find b, and then put the a and the b back in, put the point in that you have, and solve for c. So either option, this one and expand it, or what you see here. If you have any questions about any of these answers, solutions, and would like to go over them, or if you would like to talk about the grades on any of them, please do not hesitate to come and see me. Hope you're having an awesome day.